So, hi, Goran. And I think Goran Opacic is pronounced perfectly.
Excellent. There's a version of Joran from Sweden, but my is Goran. Yes.
Goran and
Sven-Göran Eriksson. Yeah, that's the same.
Ah, okay.
But I'm Goran.
Goran. Okay. And what was your first computer?
It was Spectrum, ZX Spectrum. Rest in peace, Clive Sinclair. That was like, that was the best day. I don't know, in my life that when I realized that I can do something more. So my father was a teacher in mathematics and physics, and he was like, he was doing some classes to some poor guy who didn't know maths very good. So, but his father bought him like Spectrum.
Okay.
And I was like, just in another room with a Spectrum, and they were in the other room like having a class, and I was just like, what is this?
Okay.
And I was like 10 years old or something. That was 1980s. So I was like, oh my God. So by the end of the class, I was just pushing my father, look at this. This is what is this? So he actually bought this computer from this guy. So wow, that everything started. So after that, I jumped into Atari club.
Wait a second.
Atari ST.
Why you wanted to have the Spectrum? So, I mean, for gaming or what? What you did with it?
Oh, it was like a couple of games that I saw that at that moment, but I was immediately interested in like what's the physics behind it, you know. Okay. So, and my father was a very, very good teacher in maths. So people who went to faculties came back like on summer holidays, came back to my father, and they would like bring some printed papers from the faculty. It was now I know it's Fortran, a long list of Fortran pages printed on wax machines. But they brought this to me like a present when they were visiting my father. So I was always looking at these things, like trying to figure out what the hell is this. So I was always impressed with how things work, you know. So that's something like that brought me in. So I jumped in like. Immediately started doing some basic programming in BASIC and stuff like that. So that's why I jumped into Atari Club, not Amiga Club. I was not like really a gamer ever. I always had some machines, some PlayStations or something, but I never played. Just I don't know why I'm buying these things.
Yeah.
Anyway, so I was in Atari Club more than a PC that was coming at that time.
So what was your first game or game? So first. What was your favorite game on Spectrum? You remember that?
Actually, like the first one that I was really impressed was not on Spectrum, but was on my friend's Amstrad CPC 64. It was like Manic Miner and Jet Set Willy, and then Head Over Heels. Oh my God, that was crazy game with two characters, like so you can switch between them and they can jump over one over another. So, and then on Atari it was Defender of the Crown, where you can conquer other. So I mean, super crazy stuff.
And what was your first what was your first basic application you wrote, or what you attempted to write? So what was your first?
Yeah, it was like you know what biorhythm is? Where you have like cycles.
Yeah.
So there was a guy. I was in I was like 14 or something, and I went to a computer science competition somewhere in Yugoslavia, and on the train there was a guy who was sitting just in the same space with us, like in the train, and we were just talking about some stuff about computers and Tetris that was coming at the time, something, and then we realized that he's actually selling some stuff in malls, shopping malls, and he has always some stuff selling there, And then I was actually talking to him and said, "Oh, look, this is a biorhythm thing, so you can like show someone who's his life will look like, So, and then he realized, but can I have it on paper? And I said, well, you just have to buy a printer or something. So that was my first deal, I actually managed to sell one of my first applications in BASIC. Printing or something. I can't remember what was the printer at that time that you can print on. At the end, maybe it was finished at the Commodore or something. So, but there was there's a girl in the shopping mall just with just the keyboard of Commodore. Not there was no screen, only printer. So you just type in your birthday and press enter, and it prints the biorhythm. So I always wanted to earn money from this thing, just because it was like, I don't want to waste time on things which are useless. So I just want things that people. I mean, biorhythm is obviously not something that's really.
No, but biorhythm was huge back then. And I had actually no time, to look, or no time. I always wanted to understand what's going on, but everyone talked about biorhythm back then. And I just remember some, diagrams like curve where you're doing great, and then it just disappeared, right? So it was in one point of time, it was completely disappeared. So this was actually interesting.
Yeah. But just there was always something, So that's like but that's another industry, So do you feel good today, Adam? How do you feel today? I mean, do you feel good?
Yeah, very good.
If you feel good today, the next week you'll feel bad. So so that's the biorhythm. So
yeah. The problem with me, I usually feel good, So the biorhythm doesn't apply to me, maybe.
Maybe your biorhythm is like 80 years.
Yeah, maybe. I know I'm doing well and then will die. This was like, this was like 0, 1 or 0 biorhythm in my case,
Oh, yes. Not the sinus or cosinus function. Yeah. Exactly. I love that. I like that. That's my next project. Okay. I love it.
Yeah.
So I always wanted to do something really practical. So with Atari you could actually do really a lot of things, because it had a great MIDI interface.
Was it XL 800? Atari 800?
It was like no ST
500.
Like
500 ST. This was but this is like like Mac Pro.
It was like better than PCs at that time.
Yeah. So this was like Mac Pro. I remember graphics. This was great graphics. So it's crazy.
Amazing computer, especially with a super great MIDI interface.
But it was crazy expensive back then, right?
I can't remember.
Okay.
It was not obviously because I had it. So I was not like my both parents were like teachers in high school.
Okay.
So because it was not expensive.
I already remember that Spectrum was expensive. And this Atari was a little bit more, but But when was it? 1990s?
It was at the end of 1980s. So I was born in 1974. So I went in the 1992. I went to my to college in Belgrade in the School of Electrical Engineering, and then I saw wax machines there.
Wait a second. What was the second? The biorhythm. Obviously, it was a nice your first basic program. What was the next one?
I mean, after that, I jumped into like a desktop, the printing, publishing industry, and doing some stuff where anyone who wants a new book. Okay, there's a guy who does that for like 10 times less money than other people do with because it was so easy, and there was a software called Calamus on Atari that you could do that. So. But it was always something, like.
So what you did exactly? So this was like you created like I don't know, layout software where you can just create your magazine or what? Yeah.
I mean, different things. Like before websites, you had to print stuff. So I had a school magazine. I also had books and stuff. But then like with all these things, like there's the end. There's a software called Calamus that you could do everything like for. Like Illustrator or something, InDesign or something. So you just jump to another thing, So, so I went to college, and then I saw the completely new stuff. Like 1992, 1993, I actually had a chance to test the first website, like the HTTP server. I saw it in 1993. So I did my first website in 1993. Amazing stuff, like microstations, like big screens. I was like all in Oak and SED and other Unix stuff, everything, like completely in web. I was it's also like a strange time because it was the beginning of the war in Yugoslavia, and there was like the internet connection that our faculty had at that time was really like super slow. So we actually managed to use the thing called UUCP. If you remember that, it's a thing that you can split a big file into giant number of like ASCII character emails, and then send these emails to someone else, and then he can recombine them into a file, into original. So during the night, we would just send an email to some site in America, and they would send us a file split into enormous number of emails, and so we can recombine it then. So imagine like the first Linux I ever received was through UUCP.
Wow.
It's just amazing.
Okay.
Amazing, you know. So when you don't have resources, you really you become like creative, and that's UCP was like amazing at that time. But then the internet came and stuff just changed though. So it was when you have resources, it's you spoil yourself, and then you do things the easy way. So and then like in 1995, 6, I actually. Something like that, 96, 7. I don't know. I saw Java first time, and I actually tried it on Sun MicroStation something.
Why? Were you somewhere, in the Yugoslavian back then research lab, or why you had always access?
No, it was my faculty. Like,
okay,
I was a refugee from the war, so I had like no money.
Okay.
So I would like work on my faculty computer center during the night. So there was. And it was strange because during the night, like there's always like a strange group of people, IT guys, like being there and doing stuff, hacking or exchanging ideas. And so I would never sleep during the night. So I had all these wax machines, all MicroStations, everything just for me and for a couple of other guys. And just for a couple for some small money, you have like a superpower at that time. So that's the best thing in faculty.
Yeah,
not us, it's just all these people and all these machines.
Yeah, first, what I also like is, the mood, being at night somewhere. It's a complete different, I don't know, mood, right? It's like just how to explain. It is like complete different energy if you, alone someone. Yeah. And
these days, I check if my wife sleeps. I checking is she breathing? Okay, so once I'm clear. Once she sleeps, I just take my computer and I can do anything,
But why
escape,
you are now a little bit disappointed because I thought, you would create a Raspberry Pi with a breathing sensor so you can automate the check, right? But I was in a hotel in Amsterdam and I had to check out early, and the hotel, I don't know whether it was manager but someone on the desk tell me, in the night. I'm the king of the hotel. There is no one, just me. Exactly. This was a huge hotel on the airport, Amsterdam. He told me, but everything belongs to me. It's quiet. I can do my work, and then I go home. So this was actually interesting. I thought about this a lot because,
but you can you can be alone, even with everyone alone, like in the industry. Like at these days in 1990s, when the first web things came up. I was able to be the first one in the country to build a website.
Yeah.
First one to try the CGI bin or something. Like maybe a couple of more people would actually try to connect something dynamic to a website, but it was super easy. Now it's much harder to be on some edge, so, but it's possible. It's still possible. You see that with Lambda, with serverless, and there's always something new, and you can be on that edge. You can jump to that edge and cross everything and still be alone there. And there's a lot of space for you. So you can explore.
But you actually don't have to be the first. This is the interesting part. So my impression is even if you come, 5 years later, you are one of the first because what you can do it right. At the beginning, there's lots of mess, no one knows what's going on and there's lots of wasted effort, I would say. But if you wait a little bit, after the dust, settles, so then you can do something more effective. So you can go to clients and say, now go this route, this works. Otherwise, you will spend time, lots of experimentation. I'm not really sure whether you will learn something new because, no one knows in which direction it gets. And by the way, I can also brag a little bit. I think I wrote one of the first servlet applications because I got a contract back then to create CMS system with Perl. I had no idea about Perl, so I waited until the Java server thing comes out, and this was the Java web server. And immediately after it came out, I just downloaded that. So this is what I remember. So, but this was actually
I did my first CGI bin in Perl also. Like that's connecting some. I can't remember what was the database. Maybe even Microsoft Access or something.
Yeah, but nice. So you spent time, hacking nights at some microsystems. Did you like Java back then?
On the faculty, you had C, like assembler and stuff. I mean, I really like understanding what's behind all these things. I really enjoyed like having classes about how the computer works. And that's something that we all need. We need to understand what's behind all these things. It's not just you should not just jump to like serverless and completely ignore whatever happens behind. So that's the road to trouble. I'll give you some examples later how I failed several times because I thought it was just going to be managed like something. So we need to understand what's behind. So in that terms, I really liked assembler and C. But when I saw Java, I said, I can do a lot more things. Like, so one of the things I did, like in 1998, was something like Google Maps. You're actually drawing a map, and there's the guy provided the data, and so I was drawing an applet. Amazing.
Yeah,
that's a next gen. Like just the thing is like if you're in the right place, like if you are in Google or in a position to get a lot of investment at that time, you can build Google. If you in my case, I saw something like a Google, but they didn't have like enough money or something, so you couldn't proceed. But the technology and capability of Java at that point to draw a map in a browser. At the time, when the browser was so bad, like you could have like maybe one or few tags, like for image, for stuff, a couple of HTML tags, and that's it. It's not like the things that we see today. Like, so the applets were just bringing life to the world. At that point, you could do something really complicated.
Yeah,
and people started doing a lot of really too many complicated.
What I remember, this was around 2000, a little bit later. So we had a JBoss project. And there were power plants, management of power plants, and there are huge projection screens where you see all the connections between various parts, and they were they ran in on very expensive sun stations, and we did a proof of concept, and a student created actually Java 2D application back then, which did the same in an applet or in Swing. So actually, it looks like Google Map. It was not a map. It was like you saw where there's a defect in the connections. So it was amazing, and it ran as quickly as the native C program from the visualization perspective. So Java was always great, actually, if you did it right.
Yes. I mean the thing that I can say now, like it's 2022, and today we're using some pieces of code in serverless Lambdas in Java, in AWS, the same code that was running like 17 years ago in my Tomcat or something that was like the part for resizing images or some things with manipulation of images. The same code still runs, and it's amazing that you can continue thinking and having the same tool it's only getting better, so, but the core is there. So you can enjoy the benefits of all us collecting this knowledge. So one of the notions that I had, like when I saw you jumping and trying stuff with serverless and CDK, I was really happy because I saw the thing that all these excellent Java programmers that participate in Java EE world, they all know about these complex things, distributed things, and stuff like that. So if you just try to put your knowledge into something really new, maybe there's going to be a huge jump because now all these kids like are starting from scratch. They have to learn everything again. So there's you do remember where like 6-7 years ago there was like Java 1, and I think you were also there, and the atmosphere was like bad. Everyone was feeling bad, like this is the end of Java EE. It is stuck. what is going to happen? Do we have a strategy for the cloud and stuff like that? And then all things started like to happen, like Jakarta and all other things, like Java EE world moved, but they didn't have a proper solution for cloud. And if you look at the CDK now in Java, what you're doing, it's actually what should have happened. Like that's it. That's the Java EE in cloud. And all these things that we did, like messaging and stuff like it, that we did in Java EE, that were supposed to be on one server, like in one encapsulated on one server. Now it's just distributed in real cloud. So this is it. Just take that knowledge, apply it to some new platform, and once we see all these people coming to the cloud, all these smart people from Java EE world, it's going to be a huge thing, because now kids are doing something from scratch, as I said. So there's a lot of bad things going on.
What I noticed later, it's several conversations also with these application server vendors, and we have different perspective. So we are user of the application servers and Jakarta EE servers, and the server vendors, they don't see the projects. So I had always, interesting conversations with the developers with application servers. So, for instance, I think I stopped using Java EE clusters 2005 or 6, a long time ago. And then what we did, we had, maybe 2010 as Docker came out. So, and for me, the application servers were just, productivity gain. I didn't want it to deal with the dependencies, nothing. I just wanted to write my business code and ship it somewhere. So, strangely enough, this was serverless. I never cared about the vendors.
Exactly.
Right?
Exactly.
So, from the beginning of J2EE, for me, J2EE and Java EE and microprofile was actually, I'm a one-man show consultant, a survival strategy. Without Java EE and Jakarta and microprofile, I will have to learn every single vendor, and I have no interest and no time to do that. So for me, it's like I don't care about the servers. I care about the API. I would like to be productive, and whether it runs in cluster or whatever, I don't care. I would like to write the logic. And you remember, the thin war discussion, and this was hugely successful. But it still works, and it still works on premise, and works in Kubernetes or Docker, whatever. But what happens right in the pandemic time, or 2-3 years ago, I was asked to help clients to solve use cases which are not easily solvable on premise, like having high availability with 2 data centers which are far enough, and my clients have only 1 data center. Then, encryption and rest, encryption and transit with SSL certificate rotations. Okay, now it's over. Forget, on premise.
It's too much.
We have to go to the cloud. We will pay a little bit more, but if you move to the cloud, it is completely stupid to do the same what you did on premise, because the clouds have complete different possibilities which you have on premise. So on premise, Kubernetes, Docker, whatever is fine. In the cloud, pick whatever you pick, and I mean the only answer to Java EE for me is serverless, because they are exactly the same concepts. And what you said to me, what I see the cloud like exploded application server, but I already saw that in Java 1 as Oracle back then announced the FN Java project, and I looked at how it works. This FN Java, I think this is actually like an application server, but this is exploded. There's a Lambda. There are warm functions. There was cold start and warm start. This was 5, 6, 7 years ago. So for me, I always knew we can pick servers were small, Whitefly and Payara. We could just take the server and push it to the cloud. So for me, it was absolutely the cloud native discussion. I never participated because it was clear it can work. But for me, it's why I should do that, right? Why an application server in the cloud is better than an application server on premise. But now we are talking, if you are forced to go to the cloud, because you need global caching, you need, in my current projects, we have a crazy high security requirements. Then if I go to the cloud, I won't run Whitefly anymore. Lambda is the first idea. So I'm saying, okay, can we run it in Lambda, right? And the next thing is, if you would like to upload something, why I have to do it with JAX-RS? I can just upload it straight away to S3 bucket and listen to the event, right?
Exactly.
Why
you have to use new tools, But let me give you like a 5-minute story how I became.
I'm just interested to know what happened between your first Java program and Airhack's workshop where we met the first time.
Exactly. Give me 5 minutes. I'll tell you how you made me some problems. Have you some problems to me? I enjoyed like some of your first sessions. It was like Java Police or DevOps. But I think that it was still Java Police. Maybe some of the first thing that when I saw you and my we always like 10 people in my company. Okay, so like for 20 years I have my own company.
Okay, what's the name of the company?
It's called Estech, like whatever. Estech. Like it's
okay.
Anyway, so it's so one advice for everyone: if you really like technology and you have your own company, don't sell it. Mm-hmm. Don't sell it. It's a great playground, so you can test any technology that you like, with your product. So, but if you're a business guy, if you want money, just sell it. Okay. Anyway, so the main product that we do is like a application for mobile sales. So you have people, Salesforce on ground, and maybe technicians, blah blah blah, having mobile devices, and they exchange some data with servers and stuff like that. So it's a huge application. We have 10,000 or so active users in every second. Like sending some requests to some servers and stuff like that from the. And also, like, we're exchanging data with other retailers, companies, factories, blah, blah, blah. Anyway, so millions of messages running around. And after 20 years of growth, you have a lot of mm-hmm. that. So at some point of time, when we started, so look at this. When we started 17 years ago, we actually uploaded a VAR to some provider that was providing Tomcat as a service.
Serverless.
So it worked like 18 years ago, 2022. Okay. Yeah. So it was 18 years ago. It was like the first thing how we deployed it. Mm-hmm. Okay. And there was some MySQL database there. And so it just worked. It was like a super easy, super simple solution. But after some time, you grow and then you realize, okay, you need another server and another, and then you start adding stuff. And then a couple of years after that, we actually moved to Hetzner in Germany. It's like I recommend, like, just a purely technically perfect company, like doing super great job, excellent, like super performance servers, everything was fine. So I was completely in as a business owner, but also as a technical guy. I did actually dive into MySQL completely. That's half of my love in technologies in relation to databases. So I was in completely, So
why not Postgres?
Our own, at that time, like MySQL, and I mean, even today, I would say that MySQL is like much easier. But defaults in MySQL and the way you can jump in and start using it, I think it's better.
But if you would start a project right now, would you choose Postgres or MySQL? I would choose Postgres actually, because more popular and
Well, look at that. Like, it's what does it mean more popular? Like, it's a really complicated question. But I would say, like, there are differences, mm-hmm. the way things work. I don't want to do vacuum on my database.
Yeah,
I don't care about that.
Yeah, you're right.
So mm-hmm. you see that one thing, and then when you start thinking about that, like, okay, what's important for your database to just run, and you mm-hmm. don't care about what's going on. So there's a lot of things, just to say. And also, like, it doesn't break on every single thing. I don't care about some stuff, to be super precise. Mm-hmm. Like, for example, if you do a select with and group by something, you don't have to name all the columns in the select. Mm-hmm. It's stupid not to do that, mm-hmm. but it doesn't matter, mm-hmm. If you do some count or group by. So Postgres will always say, okay, no, you can't run this. Okay. You can't run this. You can't. So, look. So that's the way. So anyway, I would in terms of what I would do today, it's more complicated. Let me get back to that. So that at that time we started using Java 2EE and tried to do something great. And then we saw you somewhere on
Okay.
DevOps or something, like preaching how everything is so easy and so cool. And then just you type in something in 5 minutes and all my developers say, are we stupid? Are we all idiots? How he can do this in 5 minutes? And I will say, look at this guy. So what are you trying to make a super complicated stuff? Like just connect two things and then that it will work, you know? So, and then we started working, and Java 2EE was a mess. You had to write so much of code to do something. So we were super happy when the things changed with Spring and stuff like that. And we jumped in immediately, moved everything again. And then again, we saw you preaching like, oh,
but wait a second. I never promoted the J2EE old stuff. So
no. I'm saying that you were preaching how things are easy, you know. So
yeah, but what I did on stage always is actually what I also do in projects. So what usually happens in my talks is, so what you see on stage, what I'm doing is usually what happens in projects, 1 or 2 years before. Because I don't like to prepare a lot, for the conferences. So if someone asks me about something, I know, okay, I offer something which I don't have to prepare. So back then, I remember I started maybe with Java 5. This was the very first. And why I did it? Because all my clients did something completely different. They had code generators and, deployment descriptors, and I really hated that. So my answer to that was like a rebel. So, okay, I go to conference and talk about how it should be done right. This was my answer, right? So this is what I did. So surprised me that I showed something complicated. So
no. Let me clarify this.
Yeah.
You showed exactly how things should work.
Okay.
And that was great. Use the platform.
Yeah.
If there is a message queue there, use it.
Yeah.
If there is just connect things, it will work.
Yeah.
You can use like Glassfish, Payara, stuff like that. And then, it looked so easy. So we dived in.
Okay.
Okay. So one of the things that we actually made, that we dived in too much, maybe, it was like implicit things, like implicit transactions.
Okay.
Distributed transactions, blah, blah, blah. Okay, let me now tell you how I became the AWS Data Hero. Okay, so that's another thing. Okay, that's a group of people from that AWS pays some like a ticket to reinvent once a year, and we always say bad things about, this product doesn't work, this product doesn't work. Always complain, but they still happy about us.
Okay.
Anyway, so after a couple of years using Hetzner, it was too much like to manage the database primarily,
Okay.
And so we decided, okay, that's it. Now we're moving to AWS Aurora, which is a managed MySQL Postgre database.
Okay.
At that time, we actually exchanged money with you. I actually paid a session with my colleague to come to your session in Munich and to check, are we doing these things properly with Java EE?
When was it?
And
roughly?
we kind of 5 years. So
okay.
So,
it's a Munich airport, so it's always nice, right?
Yeah. It's great. I mean, so just like this disclaimer. Okay, we exchange money. So anyway, we actually verified that the model that we are doing was good at that time. That's something I try to ask you a lot of questions like, is this good? Is this good? Is this good? Because I was always like worried that something will crash or something. But and then like, okay, so this is it. We did everything properly in that world. But then we moved to AWS. And like 1 year after we started, database crash. The database doesn't work. What's it? Okay. So you contact your support. We have a paid support, so they should respond in an hour. And then in an hour, they didn't fix the database.
This was AWS, right?
Yeah.
Okay.
So the whole system relies on a big giant MySQL database. That's one of the biggest mistakes, okay, that people do. So anyway, like one big database doesn't work. It's 1 hour. It's 2 hours. It's 3 hours. It's complete panic with our clients. Okay, they have mobile devices which work completely offline. Other companies that contact us have some queues with retries on their side so they can send some messages. But anyway, it's 4 hours. It's 5 hours. It's 6 hours. Like, I'm completely mad. I'm calling all the people I know in AWS, everyone, like, so in 6 hours, some team in Seattle actually gathers, and then we have a conference call, and then we talk, and then they fix something, and they say, well, look, we will just fix it now, but don't use this database in production. What? Okay, so it's like a huge database, like 4 terabytes of data. You cannot just easily copy paste that database from Ireland to Germany, stuff like that. It's hard. Okay, we tried to use the replicated database in Germany from servers which are in Ireland, and it just didn't work. It's like too big latency for that Java EE application. Which is with all these transactions and blah 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 implicit stuff. So what, like, after that, I was like completely shocked. Like that was a nightmare. Like 6 hours, super hot. If people cannot use our software, shops tomorrow in our countries, in the region, won't have milk, won't have like cookies, stuff like that. Things won't be shipped.
Yeah.
Okay, I was like, what the hell just happened? So I was trying to get the answer. So it was so hard to get to the real technical guys. So this is fixed, move to another database, blah, blah, blah. Just recreate the database, blah, blah, blah. After a month, same thing happened. 1 hour, 2 hours, 3 hours. Okay, but then I actually had a good contact, and they actually fixed it again. So, okay, that's an emergency. So look at this. So they sent me 2 guys to Belgrade, actually to Novi Sad, which is close to Belgrade, but anyway. So guys from Amazon, like young software architects. And one of the first things they asked me, like, why do you use transactions? I was just like, what the hell are you talking about? I'm using transactions all around, all these years. I cannot just, even if I want to do something smart today, like saga patterns, anything, like, it's going to take ages for me to move to something like that, Yeah. So I said, okay, look, just if you didn't use transactions before, just please don't consult me. Okay, just give me an idea what happened, So they dived into some database, and they said, okay, guy, they say that there was a transaction that was running for a month and a half in your database.
Okay.
So when there was some glitch in AWS server, the servers usually just restart, and then you probably don't notice that, like maybe a restart of a server. But the server couldn't start because there was a transaction in the log that was 1.5 months old. So it was trying to replay the logs from the transaction, and the server couldn't do that because it was 1.5 months. What the hell? I'm not running anything like for 1.5 months. What transaction of 1.5 months? It's crazy. Like, there must be something else. And I was back in my like darkness during the night. Days and nights thinking, like, not talking to anyone, like my wife, and I was just so angry. I was angry at AWS. I was posting questions and complaining, especially when they send me back, when they say, okay, we'll give you $10 for like these 2 outages.
Yeah, it's a great. So how you invested the money? So if you would invest in the $10 Bitcoins back then?
yeah, exactly. So then I was talking to my developers, and we were saying, like, okay, guys, they say that we have a transaction that was running for a month and a half. What kind of transactions we have? I mean,
the application server, right? Remembered the transaction.
So then I remembered we are still using the best advices. We are using Java JMS. JMS. Are we using distributed transactions everywhere? And they say, of course we use it. It's just implicit. It's everywhere. So why would we write transactions by ourselves? Because if we write start and end transactions, so every developer has to start and end transactions. They have to think. If we do everything implicitly, they don't have to think. That was the thing. So what happened actually was that we were using Java EE servers with distributed transactions with ActiveMQ and MySQL. When the transaction failed on MySQL side, it was still open it failed. It started, but it didn't finish. It didn't commit.
Yeah.
Okay, it didn't roll back on MySQL side. But the application server was actually running in Docker on one of the EC2 machines. And when it restarted, it started, but it didn't finish. It didn't commit. Okay, it didn't roll back on MySQL side. But the application server was actually running in Docker on one of the EC2 machines. And when it restarted, it started, but it didn't finish. It didn't commit. there was no history. There was no rollback in application server. Because application server does the rollback for distributed transaction.
But this is what I usually always say in the workshop. So what I do, I show the students always actually XA exception, why two-phase commit doesn't work. And what I also say, if you are running cluster, the migration of the transaction log is very crucial.
Yeah,
and there is usually no process in most companies. So the clusters are actually not working in most projects, right? So
we always listen to these good things. Like when Adam is saying how things are easy, we enjoy that. And then when you listen to all the bad things and all the things that you have to take care of, maybe you skip something, you skip one line, blah, blah, blah. But the thing is, it's not so easy to think about all these things, And then when you move to the cloud, you have to adapt what is native to the cloud. So in the cloud, being too tight with all having all these services connected too tight, like JMS and database and stuff, makes a big problem because everything is under one big transaction. Everything is waiting for something else. So you have to cut that. And start thinking again. And that's hard.
Yeah, in the cloud, if you don't use transactions, but you have to use something different. And for instance, for SQS, there's this visibility timeout, which for me, it is identical to transaction. And if you do it wrongly, you get exactly the same effects with transactions.
Yeah. But would you say that developers now have to be really smart and with implicit transactions and all these things in Java EE and the way you preached how things are easy, like it was easier when you just don't have to think about that.
And now you have to easy. Think. Maybe you attended the one workshop, which I didn't mention, that two-phase commit and XA exceptions are impossible to do because I had so much trouble with two-phase commit and XA for years. So I always mention this in the workshops. Maybe this time not, but we had.
Of course, I'm joking.
So, we had in one project.
Of course, I'm joking.
In one project, it was 2003. There was DB2 and Informix, and both is IBM. And two-phase commit didn't work there. This was nothing about cloud. So the problem is the two databases from a single vendor didn't understood two-phase commit. And since then, I always tried to avoid, two-phase commit. And on-premise right now, for instance, Postgres or MySQL, I like really the idea of the Besium, which, in the Besium, you can, in single transaction, write to a database and to Kafka without two-phase commit. And in the cloud, DynamoDB with DynamoDB streams, for me, is identical principle. So you can have, one transaction, a real transaction, write to DynamoDB and register Lambda, which receives, the data. But I mean, for me, it is.
But I'm afraid that developer has to be really smarter than before. Now you have to understand the problem that if you don't do that properly, you can have a lot of issues. With a distributed rollback, you can be really safe in some things. So it's moving from that platform that we did at that point, to what we do today.
Yeah,
it took us like 3 years or something. Actually, I got some money at the end from AWS because I was complaining a lot and I was like complaining at Twitter, complaining at blah blah blah. But I learned a lot. I learned a lot about MySQL and Amazon and Aurora. I just got certified on everything, blah, blah, blah. So, they actually said, okay, would you join this club of AWS heroes? And so
you have complained a lot?
So,
okay.
Yeah, so I don't complain. So, I won't complain too much, But I want to say to everyone, don't think that moving to the cloud is just moving what you all previously had to another server or to Kubernetes or stuff. I'm not a big fan of Docker anymore. That's it. That was the old thing. Kubernetes is just another way of just bringing these servers to some other location like cloud or something, but it's not cloud native. That I would
exactly.
Say. It's just
I'm glad that you see this way because I don't understand Kubernetes in the cloud at all. I don't know whether you played, or used Kubernetes on AWS EKS. For me, it is a mess.
Yeah. I'm using it in production.
I mean, you have to have, the Kubernetes users maintained. You have the IAM users. They have to be in sync. The entire, permissions concept is way too complicated in Kubernetes. So this is my personal opinion. But what interests me is if you, let's say, would ignore the simplicity of Java EE, and you would start from day one, with Zaga pattern, microservices, I think it would be worse. So what you did the mistake, maybe you moved, one-to-one to the cloud without rethinking, the distribution.
Yes.
But I think on premise, it just worked perfectly, right?
Yeah. When it works, you say it works perfectly.
Okay.
But then you realize maybe if someone would restart the server, if there was like some problem, maybe you would face some of the same issues. Like the storage in the cloud is better. You cannot replicate the things that Amazon is doing. There's no way you can have such a storage or something.
Yeah, this is what I believe. But I mean, before you moved to the cloud, it was like, I don't know how when was it, 5 years ago or 6 years ago, I guess. And of course, Aurora storage is amazing. So if you look how Aurora writes, to the disk and how it replicates the data, so Aurora is just, I would say, a engine, a stateless engine on top of really nice distributed storage.
So
it is
just an application. An application.
Yeah.
Impressive.
Yeah.
So today, look. Let me tell you what my today's stack is. So let's compare things. So today we use Quarkus.
Wow.
Mainly.
Okay. Cool.
It's 100% Quarkus now. I'm really impressed what Micronaut did and what Quarkus does for the Java world.
Yeah.
So that's also one of the things where I see that this is how Java EE should look like. Like if we talk about that bad Java 1 conference when everyone was like super sad.
Yeah.
This is it.
Yeah.
Like so Quarkus. Why I use Quarkus and not Micronaut? I say again, Micronaut is great. I really like the community. I really like what they're doing. The only thing we saw with Quarkus is like there's so many things that we already know. Okay, I don't use ORMs too much, but there is a Hibernate.
Yeah.
There's a micro profile.
Yeah.
Which is one of the best things that ever happened, Java. Okay, again. So you have all these familiar things. And okay, it starts in a second. Okay, you can easily try things and you can simulate stuff locally. And so Quarkus is the way to go. It doesn't matter if you use, even if you don't think about using GraalVM, it's super easy to develop in Quarkus and move to another level. I would say like we use Glassfish and Payara and also we still use Open Liberty. That's our, if we use Java EE, we use Open Liberty now. But when I compare the startup times or of Quarkus, not native one, that's another level. Okay, just the Quarkus with Java with Open Liberty, it's a huge difference. I can start a container in AWS Fargate in 20 seconds from scratch, and it just works. I cannot do that. I mean, whatever people say, my Open Liberty stuff starts in like 2 minutes because there's a huge thing. So it's a okay. Maybe we have like 1 gigabyte of all libraries that's packed there or something that when you do a big application. But still, I'm saying that Quarkus is super fast. Okay.
Yeah.
And then Quarkus enabled us to build Lambdas.
Yes.
In a way that I can actually write a REST endpoint with Quarkus Lambda extension for REST, for example. So I still use the same way of writing, like REST API, JAX-RS, and I use my Lambda. I'm okay. Well, this is super easy. Okay, locally I can test REST stuff. I can deploy it in Lambda, and that whole netty thing that comes in between just to enable that, it just takes maybe like extra 200 milliseconds for a cold start. It's kind of slowing it down just to start netty, but doesn't matter. The cold start is like it doesn't really exist anyway. Yeah. So I'm saying that the Quarkus was a big thing to us. So we moved to Quarkus 2 years ago when it was at the beginning. So now the stack is Quarkus.
From where you moved to Quarkus? From Payara or from where?
Yeah, I mean it was all Java EE stack. Yeah. It was we already moved to Open Liberty.
Okay.
And now we are most of the things are now in serverless Java. So we operate all these things like in AWS. When you want to deploy some stuff, some infrastructure, you deploy it in something which is called CloudFormation. You know that, just for the audience. So like with CDK, it's what Amazon did with that project is that you can actually write Java code and define the infrastructure. So we are going back in time. So we saw that.
Oh, you're also doing this. This is great. We are replicating our brains without talking to each other. And
I realized that when I saw you talking about CDK, I said, well, look, now we can talk. This is the same.
Exactly.
This is the same thing. Like we have define a GMS.
Yeah.
Okay, define SQS. It's the same thing.
Yeah.
Maybe it's not in the same class. Maybe it's not just the same annotation, but still we are doing it in Java.
Yeah.
So what AWS did is like they democratized the whole infrastructure thing and brought it back to developers.
Yeah.
So in my company, there's only one GitHub repo, and in that same repo there is a infrastructure for the project and also the code for the project.
Yeah.
So you just jump in from one class to another class and define the queue, define how you use the queue, define all the permissions to the queue, blah, blah, blah. And you use it like you as a developer, Java developer, can deploy that easily in the cloud. You don't need to ask someone can you enable this queue for me? Can you do this for me? Anyway, so the whole stack is just now in Java. We do a lot of CDK stuff also in TypeScript, which is which was the thing is it's easier if you do a lot with JSON. No, so
Goran,
yes.
Nobody is perfect, But but I give you a killer feature of CDK. So one thing is that it's Java. The another thing is it's a little bit hard to explain. But if you look at the Amazon service APIs, they are all the same for all clients. You know what I mean? So they have to, right? Yeah. So what we get the first time in the history of Java, a true reuse, because you can write, that access to SQS once. And it's going to be the same for everyone. Has to, because the Amazon API is always the same. So now what we are doing, actually, we are using Java POJOs and encapsulating interesting parts. And now comes the cool part. And we're pushing this to Nexus. And now a new developer can just say, for instance, one project can say, new Fargate microservice.
Yes, exactly.
And convention of a configuration. So you attended the workshop, you know me. You only have to say name of the service. And with the name of the service, we already say, okay, this is the name of the project. We say, okay, this is going to be, a default RAM. And there is one liner, and you have a microservice up and running. And if this changes, we push it to Nexus once again. And this new best practice is applied to everyone. And this is unique, I would say, because with TypeScript you will have to use npm or whatever. But in Maven, we store the stuff in Maven anyway.
Exactly.
This is the sign.
You just do everything in Maven.
Yeah. And reuse. I don't know whether you fiddled with Terraform, for instance. So Terraform is great, but if you use, you have the enterprise offering with the registry. But with CDK, you have the Maven, and now it comes. The state is maintained by AWS. You don't have to think, where it is. It is already a stack. With the change sets, you go to the console and you see exactly what was created. And for me, it is simplicity again, And this is what was.
Yeah, but look at what the problem is. Like when you jump into the cloud, there's always a promise that the cloud would be able to scale indefinitely. Mm-hmm. Like there are no limits. That's what's one of the issues we have to talk about now. Like the limits of the cloud.
Yeah, even but if you start with the cloud, you start with 5 IP addresses in the VPC. This is the first limit you will hit, right?
But let me give you like more things. Like for example, you want to push to your you have millions of messages per day, mm-hmm. and you want to push all these messages to SQS. Mm-hmm. You cannot do that. You cannot just put unlimited number of messages per second to some queue. You may perceive that okay, this is AWS's thing. I don't have to care about that. You can only run 1,000 Lambda functions at the same time.
Yeah,
unless you
increase the limit.
You can ask. You can push the limit more up, but okay, it won't happen automatically. So the things that you can do with these constructs, you can define a construct that you can call like unlimited queue, mm-hmm. for Adam's company.
Yeah.
And then everyone else would use that queue and put the message in it. But then you inside that construct, you may say, okay, now I'm going to handle this queue through SQS, but tomorrow I'm going to change that. I'm going to use Kafka or Firehose or Kinesis, sorry, and then stuff like that. So you can have like something like a business object called unlimited queue. Yeah. So that's just something that with this, like we need more patterns or constructs that we can reuse, just like you said, like Nexus or something. You can reuse that same thing, business thing, and what we are doing in our company, we're actually building these building blocks so we can reuse them. So developers don't have to think that much, because whenever you use a service, if you have to think about all the limits, it's not easy.
Yeah, and don't even developers. For instance, yesterday I created a code pipeline with CDK, and there are small things you have to think about. You have to create the S3 bucket first, then grant permissions to the code pipeline, create code build, and so it is nice to be able to encapsulate that in a construct. Exactly. So you then have to to think about this again, because you cannot remember everything, and if there is a mistake, you can improve it by releasing a new version to Maven. So for me, it is like very, very, very natural. But
and also, if you're doing the code pipeline, you can now there's a self-mutating code pipeline. So
exactly.
Once you do it now, you just change the code pipeline, push it to GitHub, and it will self-mutate. So you don't have to push it again.
But for the audience, we have to clarify, because this is a little meta. So how this works is that the CDK emits CloudFormation. If you think about this, a CI/CD process can be provisioned by CDK.
Yes.
And now we have the problem that the CI/CD project builds a true project. So now what you can do is, self-mutating pipeline is, you can check in one repository the pipeline which is basically empty and is executed the first time. The pipeline executes your own CDK, and now we got, the pipeline just creates itself, which is crazy.
Yes.
So I do it in the second step. So I created a hard-coded pipeline first, because otherwise, if someone sees that, it's too much. It's just like, and then it is very easy to migrate to the self-mutating pipeline.
But at the end, you just create one construct, and this is how you do that in Adam's company, So
but my company, I'm one-man show. This is the cool story, right? So
okay. So no concurrency, no.
Because you said, it's a great tip to not to sell a company or be a singleton. For me, I fully focus on technology. So there is actually.
But in your mind, maybe you can have like one day you think so one way, the other day you think another way. Like it's also multi-threaded, even if it's a single main company. But let me just focus for a second on these things like limits. So every service in AWS has limits,
but they're well documented.
Exactly, but it's you have to read it, and it's a lot. It's a lot of knowledge, for someone just coming in. How many times did you think about what is the capacity of JMS when it's running locally on premise? I never thought about like what's the capacity. I could like push unlimited. I was thinking that it's unlimited. Of course, it was not. Like even if it was local, And then some services in AWS like MySQL or Postgre and stuff. They are managed for you. Mm-hmm. And in most cases, you don't have to think about anything. Like Aurora is great. Mm-hmm. You can clone a database for developers to check something like 10 terabyte database in 10 seconds. Mm-hmm. And then it will just start, like the differences will just start recording to another location. So the storage is like super smart. So you can clone a giant database for developer purposes in a second. You cannot do that on locally. It's not easy. It's so hard to manage a database properly, and with all these readers that like have a latency of like a couple of milliseconds, there's no chance you can compare to that. But then don't forget that it still runs the same MySQL code or Postgre code. Mm-hmm. It's just the storage layer that is replaced, and some of the things are replaced just to be for them, like, but still it's MySQL with all the bugs, all the issues that MySQL has. Mm-hmm. So if you really want to dive into something that Amazon is like kind of providing a guarantee, then maybe you should think about stuff which is different, like DynamoDB database,
Exactly.
like stuff like that. So, which brings us to another thing in AWS also, like AWS with DynamoDB and Lambda forces us to make projects simpler, to make queries simpler, to make everything simpler, so we can run millions of them in parallel. Just forget about this giant, big, complex function that you had, like with implicit transactions and stuff like that, connecting to many services. Split it, make like many small calls, and then it will work in cloud. So so this is something like with the Dynamo, we have to simplify the model of thinking and the model of database and stuff. So if you do that, you will be able to scale.
Yeah, but one thing which I see differently is the issue with two-phase commit was not us developers. The problem was the business department, because they wanted to have everything consistent. They wanted to say, okay, everything has to be consistent all the time. But if you move to the cloud, you have to explain. We have to think about consistency twice. First, consistency is expensive. So if you go to DynamoDB, you pay way more for consistent transactions than for eventual consistent transactions. And but it is not always possible. So the trouble you had, you attempted, to write to the database and JMSQ at the same time. But what you could do, you could use Debezium. Back then was not Debezium, of course, but you could use Debezium, but it would be not the same. I would say not at the same time. You would see some delay. And what happened now? Nobody has a problem with the delays anymore. Everyone is accustomed to slight, asynchronous processing. So the world changed. The expectation that everything has to be consistent is no more there.
Exactly.
So, and
especially if you use like external services. If you use external services, like if you're sending emails through SendEmail, so through SendGrid.
Yeah.
If you're sending text messages through Twilio or something, then there's no rollback.
Yeah, exactly.
Okay, so you have to think about that now. And previously, with all these things integrated, these things like sending 1,000 text messages to a single person during the night, that wouldn't be happen. That it didn't happen because of all these implicit transactions and distributed way of thinking and rollbacks. It just didn't happen.
Yeah.
But now with this, like one of my clients actually got like hundreds of text messages during the night. So then I said, okay, this service needs to be somewhere else with a check, duplication check and stuff like that. And then we had to invest in checking, okay, does our service provider provide a check for deduplication check also? Just like you said, with SQS matches, we can also check it for duplication, stuff. So we need to think more, but it's possible.
Yeah,
you can do that, but it's a bit harder. Of course, it's like business wants things to be done easily. I want to be able to easily, as a business owner, I want to be able to easily replace a developer with someone who will just jump in and write code and not without having all this knowledge. So it's hard to jump into all this AWS stuff. There's a lot of things you have to learn these days. So, but still, see, Java still works. Like for all these years, I still write code in Java, and I can compile that code and run it like in super fast, super scalable in AWS. It's amazing, So with GraalVM, we are compiling. Just one thing for everyone, like maybe it's a good thing to do. Like we always compile. Both in Quarkus. First, we compile to Java, then we compile to native. We always provide through a stack both executables for the project. So in CDK, you can choose. Okay, for this function, I'll go native. For this function, I'll go with Java. So you can try and move safely, like because it's not easy. Like that whole thing is. Did you ever read like Quarkus README file, like release notes? It's like hundreds of things all these things you have to learn every time. So many changes, incredible.
Yeah.
How can you have a track of all the things that can impact you? Yeah. It's super hard.
Yeah.
So I'm saying that you have to if you want to move to native, try compiling everything all the time. It's just a couple of maybe like extra minute of compilation time, but you can have both things deployed and you can switch and test, of course, in production.
And another tip, maybe you are using this already. What I use in my project, I do exactly the same, but I'm using EC2 Spot instances with user data to compile the native images. They cost almost nothing, and they are crazy fast. So I have, an ARM instance and an Intel instance. A Spot means this is very cheap, huge instances, and they compile the GraalVM code really fast. So what amazes me, we do almost the same. And the last time we met was 5-6 years ago. I never heard about you. You just pinged me on Twitter, and we do almost the same. And by the way, in all my projects, I also using Quarkus. For asynchronous Lambdas, I just use nothing. So I don't need any dependency injection. It's just even simpler. It looks Java like 1995. There is just Java and nothing else. So I use Quarkus.
And let me tell you, pure JDBC. That's what I do now.
Yeah.
No more ORM, Hibernate stuff just pure JDBC if I need it.
Yeah.
That's it.
Yeah. Yeah. And I try to use DynamoDB more. And the reason is, maybe we should meet again and talk a little bit more about AWS and architectures and costs especially. So the great story about DynamoDB is there is nothing to provision. So you just say, I would like to have a new table with CDK, and you have the table. So the downside of DynamoDB is you have to rethink how you model, the partition key and sort key. And I like it, but this is completely different to Postgres or MySQL. So, but if you go with Aurora or with RDS, it takes at least 5 minutes, to provision the database, and the CDK is more complex. You have to think about more things, like you will need at least have to KMS secret, which is shared between Quarkus and Postgres, and DynamoDB is just, I would say, DynamoDB is cloud native because
it's exposed through a HTTP API.
Yeah, it started in the cloud. And why I like Dynamo is there was a DynamoDB paper. And on the DynamoDB paper, most databases like Cassandra are based. So it means if you use Dynamo, you use the real NoSQL thing, and most of the database are using DynamoDB anyway. So at the AHEX workshop, I did a few years ago, Persistence Day. So we actually look at the DynamoDB paper, and I explain, all the concepts, how NoSQL is working with, the quorum and how the instances are replicated, and now we can just use it. I mean, this and this is, I would say, if you go to the cloud, look at the cloud native services first, because or stay at home. You can also run still your Kubernetes on premise. So you shouldn't go to the cloud. But sometimes I see, people are going to the cloud and they don't know why. If I ask them why you have to, use the cloud service, they say, yeah, we have to. They're like, yeah, but this is a mess. Because if you do the same, what you did at home in the cloud, it probably won't work, or it's going to be very expensive.
I would say that the question of going to the cloud is it's not that I have to, that's something that I want, I want to focus on what's really important on this edge, like the next generation of all in AWS of all these things is like no code, like integrate stuff,
Mm-hmm.
It's not easy, but still you have state machines, you have queues, you have all these components.
Do it this next time. We should talk about this next time.
Okay.
Otherwise, it's going to be too long. Where
Exactly.
people can find you on the internet? What's your company? And can they hire you for services? Are you selling something or no? If someone would like to have a great system, can you hire you? Or
everyone can hire me if there's something really interesting, and that's these days we are all connected and easily connected and find each other. But the best way to find each other is on Twitter. Like it's that's the way to go now. It's just like I'm so old that I have. First name, last name on all services. So Goran Opacic is on GORA and OPACIC on every service. On Gmail, I have just plain Gmail address, like no numbers extra. So
Okay.
I'm saying that being so old has some like cool things. Anyway, like Twitter, I have a blog post made about cloud.
Yeah. What's your blog? But
yeah, okay, madabout.cloud.
Okay.
It's mostly about databases, but I'm trying to make a bridge between old stuff and new stuff, like serverless and relational databases. It's not easy to connect these worlds, So I'm trying just to bring people to the cloud so they can see that it's not that they must go to the cloud.
Yeah.
It's a pure love now.
Okay. Okay, cool. So thank you. It was fun. It was really fun to meet you again.
I mean, you always like cheer up the room. That's the thing. Like, so that's why I liked all these presentations so far before. Like, I hope the DevOps will run again this year so we can meet there. So that's the place to go.
Perfect.
Yeah.
Thank you.
Great. Thanks, Adam.